Thank you. That was a very nice introduction. So yeah, how to do evaluation-driven product development. So you built a product, right? And you wrote the prompts, and you send your prompts to an LLM pipeline, and the LLM takes the data, generalizes your prompts to the data, the input that it receives from the customers, and replies to it. And then you look at the data, see what happened. The customer sent this, the LLM replied that, looks fine. Maybe you see some little problem, maybe you tweak it. The problem is, oh, I'm behind one slide. The problem is, how are you gonna look at all the data that comes from the customers, all the requests they send? There's thousands of millions of requests. Also, you write the prompt, yeah, but it's really hard to write the perfect prompt also in a way that the LLM will interpret it like you want it to interpret it. And then the LLM will do its best to generalize the prompt to inputs that it's never seen, but it will always do it in ways that you don't really expect. So this plan doesn't really work. Let's see how we can make it work. So yeah, I work as a technical product manager at Tiqets. We sell tickets to museums and attractions all over the world, and that means creating a lot of order out of chaos. We integrate with a lot of suppliers, a lot of products from everywhere, everyone structured and written in different ways, and we need to structure them all in a cohesive way so that our partners can trust them, and so that we can build a product that works reliably. So how do you know that your LLM pipeline works? Well, evaluation is all about measuring accuracy, relevance, coherence of your pipeline, also related to business metrics like customer satisfaction, conversion. And the reason why I want to evaluate this pipeline, is so that I can drive systematic improvement. When I build something, I always think this will break. The question is, how do I notice that it broke quickly so that I can improve it? And when I do, how do I know that I really improved it? That's a big question here. It's a very old question, and it's still relevant, even more than ever. So yeah, you fix a problem, maybe you introduce side effects. You know it very well. You fix this bug, there's 10 bugs over there. And there's a new model out there. Should we switch? And if we do, are those the best prompts for that model? It's very difficult. So let's do a little pre-mortem. I built a product, and it didn't work. So what went wrong? Well, I don't know. Because I don't know anything about that product. I just made it up. What were the inputs and outputs? What was I trying to do? What did I think that the problem was? And what did the LLM think that the problem was? And what did I think that I had to tell the LLM so that it would understand the problem that I think I see? It's very complicated. So let's break it down. There's the 3 steps from before. And every step has a problem. The human builder, that's us or me, there's a lot of data. There's no way that I can understand every possible way that customers will talk with my chatbot, for example. It's a problem of a sample versus the scale. Then when I think I understand what the problem is and what the LLM is good or not good at, I need to try to specify the problem to the LLM so that it will solve it. And then the LLM will do its best to apply that prompt to input that I've never seen before, it's never seen before. So it's a generalization problem. Let's look at each of these problems one by one. The first problem is comprehension. There's no way that I can understand everything that's happening. This looks, by the way, a lot like those heist movies, you know, and yeah, we have to go and rob the bank, but we need the blueprints, and we cannot find them because they don't exist. And then we need to break through the door, but it's impossible because it's made of unobtainium or something. So, but in the end, there is a movie, and they do it. So how do we get there? That's what this is about. Second problem is specification. As we said, how do we specify the prompt in a way that it causes the LLM to do what we want? And also, and very important here, is what is good enough. That means that there is no generic answer for, oh yeah, this is the perfect prompt. It depends on what you're trying to do, what is important for your product. In some products, it will be very important to get something very right. And other things, well, it's okay. In other products, other things will be more important. What trade-offs, what are edge cases that matter, what does success look like? It's all about you as a human understanding the problem and understanding what's important for your product. So that's interesting here. We started with AI, but actually the focus is on humans. That's good, because we get to keep our jobs. The third problem, generalization. Generalizing your prompt so that it applies to the input that the LLM will get, it's really difficult. And a perfect prompt cannot compensate for fundamental limitations of your model. So you may need to, decompose your task to more to different LLMs instead of just doing it in one, or fine-tune it for your domain, or use retrieval augmentation, like call other tools to get the data that you need. So, to recap, we have a problem that we don't understand. We write ambiguous instructions on how to use it, on how to solve it. We give it to an LLM that we also don't understand. And in the end, the LLM applies the rules in unexpected ways. So how do we solve this? There's a way. I like to call it discovery first evaluation, because first we need to understand the problem. First we need to understand deeply, what do we want, what is possible, what can go wrong. And once we make changes, we need to understand the other fixes work. So this is a process to get that done. And the first thing is to understand what's happening. So that means looking at real interactions between users and the LLM and understanding what did the customer ask, what was the context. For example, if I'm asking, what will change in my pension? Well, I need to know the details of your pension, right? If I ask, hey, what should I do in Groningen today? I need to understand, but is it raining? Are the trains working? I don't know. What's playing in the movies? What type of traveler are you? Are you with your family? What do you like? All this context is important. What the LLM do and what the LLM return. And this is backwards, right? Yeah. I think I filled up the animation backwards. So let me introduce two concepts. The trace, and that is like a log line, right, of everything that happened. So that's what the user asked, every context that the LLM could see, like a previous conversation, other tools that it can call, and what the LLM decide as steps to process, what was its processing steps, and then what response it generated. This is an example. So yeah, what I just said. The user asked for a question. Hey, I'm going to Groningen and I'll rent a bike. What can I do? And then the LLM has some context of previous history. It identifies the intent of that customer. It takes a bunch of steps to generate the answer, and in the end, it makes a suggestion. So this is an example of a trace. Second concept, a failure mode. That is the specific way in which your LLM failed to do what you wanted. For example, hallucination. And hallucination is funny. I'm going to come back to that slide, by the way. Because we talk a lot about hallucinations. And yeah, I know that sometimes the LLM will interpolate to some things, and other times it's just out of its water, and it will extrapolate to input that it didn't expect. But it's also true that an LLM is a probabilistic model. And hallucination is like anthropomorphizing it. It's attributing it human qualities. So the LLM just generalizes beyond its training data. And another way to think about it that I quite like is that, and it's not perfect, is that it's always generating text probabilistically, right? The difference is sometimes you like that, and sometimes you don't like what came out of that. So it's like I wrote here, I draw here the peaks, the bright spots is where you like the output, and the dark spots is where you don't like the output. And you can change your prompt to tweak things to move these areas a bit around until it maps with the areas that you care about. So in this area, this thing here, the price of my product needs to be correct. So here I want very bright. Here, does it use this word or that other equivalent word? I don't care that much. So that's what you can do. Yeah. Back to the failure modes. Specific way in which an LLM can fail. Hallucination. It lost the context. It forgot that I told the LLM that I was by bike. It didn't follow the instructions in the prompt. It has bias because of its training or just because of the model that it is, etc. There's a lot of this stuff. we'll come back to those two concepts in a bit. And an important concept here is that you can automate to amplify insight, but not to bring insight. So first you need to understand what the problems are. There's a lot of human focus here. And then once you know that, you can use an LLM to automatically find how prevalent those problems are. Problems that you saw. I saw that sometimes it responds in French. Does that happen often? I don't know. Well, an LLM can go through all the traces and see how often that happens and when. What is the context that causes that? But if you don't know the problems, what the problems are, and you don't know what you care about, you don't know what is important, then what are you going to automate here? Yeah. What's this about? Same thing. This is two examples of an LLM judge. So first. You have to ask very clear questions of what does it mean for you that something is correct or not. So the first attempt, hey, I have this trace. Is it good? And the LLM says, well, I don't know. It could be shorter. Yeah, but does this even matter? This doesn't really bring us anything. Now the other one, I wrote an automated evaluator for transport suggestions. So the LLM is suggesting me to take a transport. Is that correct? And then, well, that LLM knows about, well, this is a Dutch city. Doesn't make a lot of sense to drive around Groningen. Maybe you should take a bike. So the parking is going to be expensive. So here, this we can use. In this case, the LLM should not have suggested me to drive in the city. And this comes because I understand the problem, I understand the product, what is important for me, and I wrote a very sharply focused evaluator for this situation. So, error analysis. That's the first step, knowing what's going wrong. So the first step is to get a clear picture of the failure modes, understand where does the LLM pipeline break down? What are some concrete examples of things that the LLM did and you didn't like? It shouldn't do that. At the beginning, you have to do a lot of this because you have nothing. You don't really understand what's going on. And later on, you have to continue doing it because things will always change. You change your prompt, the new failure modes come up, but less. And it's very important, and I hear from other people working on this that they struggle with convincing their managers or the product managers to dedicate time to this. They just want to automate fast. But if you don't know what the problems are, you really can't automate. Yeah, and this is, yeah, sorry, I'm making a mess with the slides. So this is what I mean by error analysis. And the first step is very important. Which is going from the traces, the production traces, and just look at them. Look at all the production traces. Look at a bunch, a good amount, a few hundred of production traces, and write down what you see. Here I see that it responded in French unexpectedly. Here I see that it kind of got it gave a very long response, etc. And you have to do it by hand. You still don't know what you're going to find. You just writing down what you notice. And after you do it for a while, you will notice some patterns. And then there's, so the first thing is called open coding, by the way, is giving these open codes of, hey, I noticed that this is kind of long. And when you see patterns, then you do what's called axial coding, which is to group those similar failure modes into categories. For example, the category of when the LLM gave the wrong suggestion on which transport to take. The category of when the LLM just it ignored the request of the user and it suggested something else, etc. And once you see some patterns, then if you go back to the traces that you already saw, maybe you see more or less. At some point, you'll have enough. You'll look at more and more traces and you don't learn anything else. Typically, maybe you have 100, 200 traces. And then you have a nice evaluating data set. So you have good examples. These are the problems that I see. And this is how I categorize them. And it looks a bit like this. So first, you wrote down for each trace, hey, you know, in this case, it recommended the Young Frank house for tomorrow, but it sold out. So it should have called the MCP to see is there availability for tomorrow. And then you give it a little quote here. Well, it didn't check availability, and this for everything. And once you have them all, or you have a bunch, you start categorizing them. You see common things, like for example that it didn't do proper search or filtering, or it didn't look at the geography of where the user was located. So now we have a very clear view of the problems that we noticed. Doesn't mean that it's all of them, but we noticed them. I'm not going to get into this, but if you don't have enough queries from the customers, you can generate them yourself with LLM, and there's a way to do it so it's a bit less bad, but you're still making it up. So yeah, it's not a great idea. If you don't need to, don't do that. Okay, so now we saw things. Now we understand the problem, and I understand that you understand the product to start with because you're building it. So we did this is the thing from before, and we solved the first part. Now we understand what's going on in the data. We took a sample of that. Now there's more problems because we still specify the prompt ambiguously, and the LLM will still generalize wrongly. So what do we do with that? Well, the key there is to now measure how often those problems that we noticed, how often do they happen, and that will help us, especially when we make tweaks. Then we can measure again and see, well, did it really help or did it make things worse? And by the way, you could have an idea of, you know what, all this looking at traces and stuff, I'm just going to look at business metrics. If conversion is up, then the thing works. Okay, until you get a lot of chargebacks because you promised free popcorn and the customers are demanding refunds. So it works, but it also doesn't work because that's only a very narrow view of what's really happening. So now we're going to create an automated way to look at the traces and identify for each category how often it happens. Once we have that, we can iterate and iterate systematically on prompts. We can try new models. We can try a new pipeline architecture, splitting up the LLM in different steps. And this is the slide from before. Like now we have the insight to automate evaluation. We know what's going wrong. And now we can automate this evaluation. The automated evaluator will only, if it doesn't have insight, it will only find generic failure modes. It doesn't know what's important for your product. It has its own bias. The example from before. This is an example. So sometimes you don't need to write an evaluator using an LLM. If you said, I want my output in JSON, well, then just write a Python function that checks if it's JSON. In other cases, you do need it, like, time sensitivity. It needs to take into account that the traveler is a planner and is buying tickets way ahead. There you need an LLM. So if you don't need to use an LLM to evaluate, it's much better because it's just algorithmic. You can trust it more. You can write a unit test, and you know that it works. Okay, so how do we do this? So this is the idea, and this is the wrong idea. But let's start here. So we have a bunch of labeled examples. That's what you did. You look at all the traces, you made categories, and now you have a list. I see these categories of problems. This is an example, a few examples of each category. This is what went wrong. This is an example, examples where the LLM did the right thing. So, I can iterate. I can include some of those in my prompt. I can use them to verify if the LLM is doing the right thing. I feed it the input, and I verify did it get the input that I wanted or not. The problem is you're sort of giving the LLM the answers to the test that then you're going to use. So what people do very, very simply is split it up. So you take like about 20% of the traces. You're going to use them for as few short examples that you can include in your prompt. And you will see which ones work better. You iterate on that. Then you have another subset, for about 40%, which you will use when you are playing with the prompt, tweaking things to see if it works. And once it works here, then you use the other 40% to measure if did it generalize correctly, or did it only perform well in these things while I was watching, but when I'm not watching, then it does the wrong thing. So this green stuff is to test generalization. So yeah, the two steps of building an LLM judge is writing the prompt, checking how well the prompt performs, and iterating on it. This is an example of an LLM as judge prompt, and the key is to focus on only one failure mode. This is difficult enough, so make it very narrow on that one category of problem that you saw. I saw that in this case, yeah, too many alternatives. So I want 10 concrete options on how to travel, and if you don't have enough information, ask for more. Give it a very clear task, explain exactly what it means to fail, what it means to pass. Give it a few short examples, and you have to. It's useful if you choose tricky examples, examples that are especially difficult, that are interesting. But of course, you also don't know how the LLM will handle this, so you will have to iterate on this, and in the end, and tell it exactly how you want it to answer. It's good that it answers as a JSON or as some structured format, and then it tells you, well, either fail or pass, and a reasoning of why. And you could say, well, you know, but maybe if something is not too bad, I could have like, give me 0 to 10 how bad it is. The problem is, this is already really hard. If you also want to tell it a number, if you also want it to tell you a number that more or less says how good it is, it's even harder, and it's even harder to use it. So pass or fail is keep it simple. Now, this is a way, but there's this thing called DSPy, which is a declarative framework that basically you describe your intent in Python, and it will create the prompt for you. It's sort of compiler to prompt. And it has more tools like automatic trying to optimize that prompt for specific models. Trying, hey, what happens if I threaten the LLM? And it's also useful because as you iterate on your prompt, you add maybe some specific tweaks for some edge cases. If you write it in Python, you can keep it maintainable. If you have a huge wall of text of 10 pages, how are you going to maintain that? So I'm not going to go deep into this now, but I just submitted my talk for Pygrunn, so maybe I'll go in depth later next year in May. We are at the last step, measuring the performance. How much does the LLM judge agree with your judgment? That's in the end, you have an automation that you fed it your categories, some examples, and the judge says, yeah, in all these traces, the LLM did the wrong thing. And in all these traces, the LLM did the right thing. We need to know how good the judge is. So how often does the judge say no when you said no, and how often does the judge say yes when you said yes? And you want both, right? Because otherwise you just write a judge that always says no, and well, it will always agree with you when you said no. And how much do you need? What percentage is good? It really depends. Like in a medical field, maybe 90% is too low. And in other cases, maybe 70% is enough. So it's up to you and to see what is important for your product. So we have now the entire cycle. We are checking by hand what's happening. We have a catalog of failure modes that we identified. We have created an automated process that says how often does it problem happen? Do our improvements work? Did we introduce more problems? So we went from qualitative insights to some quantitative metrics of this is what is happening. And of course, it's only identifying the problems that you saw. So you need to keep looking at the real world traces and see what did you miss? What are things that look good, but actually were not good? And now you can iterate systematically. You can measure, improve your prompt, improve your architecture, and see, yeah, it worked. Judge says yes. So this is the slide back from the beginning. Yeah, now we keep analyzing the production traces, keep iterating the prompt, keep measuring how well it works, and good luck. Any questions? Oh, if we want to go deeper, by the way, in camera 1, after this talk, there's Dr. Ayushi Ratsogi from the University of Groningen will talk about the same thing, very similar, how to tell when LLMs are lying and what to do about it. So if you want to go deeper, maybe go there.